In our lesson today, we're going to have another practice on determining if the data in a table represents a proportional relationship or a non-proportional relationship. Okay, we need to ask ourselves the question, how can you distinguish relationships that are proportional from relationships that are not proportional? Okay, and so what we're going to do in the box that we see here, we're going to remind ourselves from the last lesson what it means for a relationship to be proportional and what it means for a relationship to be non-proportional. A proportional relationship between two quantities means that they have a constant unit rate. Okay, all proportional relationships have a constant unit rate. Okay, that this then means that all ratios are equivalent. Okay, so each time you set up the ratio, you're going to simplify it down and see if you get the same unit rate. If you do get a constant unit rate, well, then it will be a proportional relationship. A non-proportional relationship between two quantities means that they do not have a constant unit rate. Non-proportional relationships do not have a constant unit rate. Okay, well, you can tell if they don't have a constant unit rate if all of the ratios are not equivalent. Okay, all ratios are not equivalent. So when you simplify them down to the unit rate, if they are not all equivalent, then that means you're dealing with a non-proportional relationship. And the constant unit rate, how do you find that? Well, you find that by dividing both parts of the ratio by the denominator. Okay, whatever the value of the denominator is, divide both parts of the ratio by that denominator. That will get you to a unit rate. Remember that your unit rate is always some value over 1. Your denominator needs to be a 1 in a unit rate. In our first example, we're told that a computer programmer charges customers per line of code written. We're going to take a look at the data that's in the table, and we're going to determine if there is a proportional relationship between the cost and the number of lines of code, or if there is a non-proportional relationship. Okay, so we see our lines of code in the first row of our data in our table, the cost in dollars in the second row, and underneath of the show your work spot, we're going to set up our ratios. Again, we want to know the cost per line. So I'm going to put my dollars in the numerator of each ratio, and I'm going to put the number of lines in the denominator of the ratio. So looking at my table, all right, the first cost in dollars was $1,000, and that was for 50 lines of code. We need to take this ratio and simplify it down to a unit rate. Remember that a unit rate has a denominator of 1. So we're going to have to scale from 50 to 1 by dividing by 50, which means we'll do the same thing to our numerator. Again, divide both parts of the ratio by the denominator. 1,000 divided by 50 is equal to 20. So this simplifies down to a rate of 20 over 1. Next set of data from the table, it was $2,000, and that was for 100 lines of code. And again, we're going to get a unit rate. We're going to have to divide by 100. The denominator was 100. So if we do 2,000 divided by 100, that again is going to give us 20 over 1. The third set of data says that it was $3,000 for 150 lines of code. Get your unit rate by dividing 150 by 150, and then do your cost divided by 150. 3,000 divided by 150 is equal to 20. So we have another ratio there of 20 to 1. And finally, our last set of data said it was $4,000 for 200 lines of code. Get your unit rate, again, by dividing by the denominator. 200 divided by 200 is 1. 4,000 divided by 200 is going to give us 20. So we have a unit rate of 20 over 1. Notice that in each case, each ratio simplified down to the same unit rate of 20 over 1. So again, looking right here, we set this up as dollars over lines of code. And each time we got a value of 20 over 1. All right, put a star right here. This constant unit rate that we got, that 20 over 1, this is called your constant of proportionality. And we use a variable to represent the constant of proportionality. We use the variable k. In this example, k is equal to 20 over 1 or 20. Either one of those would be an appropriate way to write the value of k. The constant of proportionality k is related to the constant unit rate, but it does not contain the labels. So if they only wanted the constant of proportionality, just give me that number, 20 over 1 or 20. If they wanted the unit rate, that's when you would tell me what the unit rate is. Let's write the unit rate over here. The unit rate, what does 20 over 1 mean in this example? Well, 20 was your dollars. It was $20 per line of code. Every line of code cost $20. Now, underneath, we have a couple of blanks that we need to fill in. It says that the two quantities of cost to line of code, well, since they had the same unit rate, we're going to say that this was a proportional relationship. And we know it was a proportional relationship because there is a constant unit rate. There is a constant unit rate of $20 per line of code. So when you have a constant unit rate, you have a proportional relationship. In our second example, we're told that the table shows the number of students that buses can transport. We're going to look at the data in the table and again, try to figure out if there is a proportional or a non-proportional relationship. And if there is a proportional relationship, we're going to identify k, that constant of proportionality. So looking at our data in our table, okay, the way that we're going to want to set up our ratios, we want to know how many students per bus. It even says it right there, students per bus. So let's set up our ratios as students, all right, over the buses. And looking at our first set of data, we can see that there are 144 students, and that would be 2 buses of students. We again need to get a unit rate, so we're going to have to divide our numbers by 2 in this example. 144 divided by 2, well, that's 72. So we get 72 over 1 as our unit rate. The second set of data, 216 students were on 3 buses. Let's get our unit rate by dividing all of our numbers here by 3, the value of the denominator. 216 divided by 3 is 72 over 1. Then we're told 288 students fit on 4 buses. Get our unit rate, divide by 4, divide by 4. 288 divided by 4, 72 over 1, again, is our unit rate. And then finally, we're told that 360 students fit on 5 buses. Get our unit rate this time by dividing by 5. If you do 360 divided by 5, well, again, you're going to get another unit rate of 72 over 1. Look at the unit rates. Every single time, the ratio simplified down to a unit rate of 72 over 1. This value right here is your constant of proportionality, k. K in each case was 72 over 1 or just 72. 72 over 1 is equal to 72. Since the constant of proportionality k is the same value, okay, we got the same value for k in each example that we did, there is a proportional relationship. Okay, there is a proportional relationship in this example. When you get the same constant of proportionality, the same value of k, again, that shows a constant unit rate. And let's write down the unit rate right next to K. For the unit rate, 72 over 1. In this case, 72 was the number of students on one bus. So the unit rate is 72 students per bus. Again, remember K, the constant of proportionality, does not have the labels. The unit rate is where you will include the labels, students per bus. In our third example, this table shows the number of miles a plane traveled while in flight. Use the information to find the constant of proportionality K if it exists. So we can see the time in minutes in the first row and the distance in miles in the second row of our table. And we're going to see if there is a proportional relationship between the miles and the minutes, okay? Is the number of miles proportional to the number of minutes? So we're going to set this up as miles to minutes. Miles to minutes. So looking at the first set of data in our table, the plane can go 270 miles, and that was in 30 minutes. Let's get our unit rate here by dividing by 30. If you do 270 divided by 30, that's going to give you a value of 9. So the unit rate there is 9 over 1. The next set of data, the plane goes 405 miles in 60 minutes. Get your unit rate by dividing each of the numbers by 60. If you punch in 405 divided by 60 into your calculator, you're going to get 6 75/100. So our unit rate there is 6 75/100 over 1. Next, 810 miles in 90 minutes. Get your unit rate, divide by 90, divide by 90. 810 divided by 90 is equal to 9, so our unit rate there is 9 over 1. And then finally, 1,215 miles in 120 minutes. Get your unit rate by dividing each number here by 120. Divide by 120. 1215 divided by 120 is 10 125 thousandths. Okay, so we have a unit rate of 9 over 1, 6 75/100 over 1, 9 over 1, 10 125 thousandths over 1. Okay, notice that not all of them are equal to each other. You have 2 of them that are equal to each other, but not all of them are equal to each other. Since the unit rates are not the same, right here, the value of K, well, it doesn't exist because they're not equal to each other. So for K equals in this spot, we're going to put n/A. It's not applicable. It doesn't exist. There is no constant of proportionality in this example. Why isn't there a constant of proportionality? Well, because right underneath where it says, is there a proportional relationship between time and distance? No. If there is not a proportional relationship, then there is no value of K, the constant of proportionality. So this was an example where it was a non-proportional relationship. So let's go ahead and write this in. The relationship is non-proportional because there is not a constant unit rate. Since there is no constant unit rate, there is no constant of proportionality. This is a non-proportional relationship. In example 4a, they tell us that the table below shows the hourly charge to rent a bicycle at Supercycle's bicycle store. Find the constant of proportionality, which we're going to have to do that by finding the constant unit rate for the data found in our table. So we see our time in hours in the first row, our cost in dollars in the second row, and we want to know, in order to rent a bicycle, how much it costs per hour. So for our ratios, we're going to have to set these up as dollars to hours. So taking a look at the first set of data, we see that it costs $24 for 2 hours to rent the bike. Get your unit rate, divide each number here by 2. 24 divided by 2 is going to give you 12, so the unit rate there is 12 over 1. Second set of data, it's $36 for 3 hours. Again, get your unit rate by dividing each number by 3 in this case. 36 divided by 3 is equal to 12. All right, third set of data, I should say, it was $48 for 4 hours to rent the bike. To get our unit rate, we'll divide each of the numbers here by 4. And 48 divided by 4 is 12. So again, we have a unit rate of 12 over 1. And then finally, it was $60 for 5 hours to rent the bicycle. Divide by 5 to get to our unit rate. Divide by 5 to get to our unit rate. And again, 60 divided by 5, we get a unit rate of 12 over 1. Each unit rate simplified down to 12 over 1, so the constant of proportionality, that value of k, equals 12 over 1 or 12. Either one of those is an acceptable value of k. Again, all of the values of k were equal, so the relationship between the cost and the time rented is a proportional relationship. And if k equals 12, let's write down what that means for the unit rate. The unit rate equals, well, the 12, that was your number of dollars, so it was $12 per hour to rent a bicycle at Supercycles. In example 4b, it says that the table below shows the hourly charge to rent a bicycle at Pedals Rentals bicycle store. Find the constant unit rate. So again, we need to know for this bicycle store the cost per hour, dollars per hour once again. So looking at the first set of data, it costs $4 to rent the bike for half an hour. We need to get our unit rate by dividing by 1/2. Okay, a half divided by a half is 1. 4 divided by a half, if you put that into your calculator, equals 8. So we get a unit rate there of 8 over 1. The next set of data says that it costs $8 for 1 hour. This is already a unit rate because the denominator is a 1. I don't have to simplify, so I can move on to the next set of data. It was $12 for 1.5 hours of renting the bike. Get your unit rate this time by dividing by 1.5. So if you punch that into your calculator, 12 divided by 1.5, that will give you 8 over 1. And finally, with the last set, it was $16 for 2 hours of bike rental. The unit rate this time, if we divide each of these numbers by 2, 16 divided by 2, we get a unit rate of 8 over 1. So looking at the 4 unit rates this time, all of them were 8 over 1. So this constant of proportionality k equals 8 over 1 or 8. And again, since all of the values of k are equal, since all of them were equal to 8 over 1, the relationship between the cost and the time rented is a proportional relationship. Okay, and let's write down the unit rate again next to k. The unit rate for this example, 8 over 1, means that it was $8 per hour to rent a bike at Pedals Rentals. And so our last question wants to know which bicycle store charges more per hour. Well, we just saw right here at Pedals Rentals, it was $8 per hour. And in our last example, right here for Supercycles, we saw, right there's our unit rate, it was $12 per hour. So that was the higher unit price. So it was Supercycles. Supercycles charges more per hour to rent a bicycle.